Welcome back to the second session, in which we continue with mechanical energy in particular. Starting with kinetic energy. Kinetic energy is the energy of a moving object. Whenever an object is moving, we talk about kinetic energy. Take, for instance, a car. Once it starts moving, it possesses kinetic energy, and that is given by half mv squared, where m is the mass in kilograms and v is the speed in meters per second. Now, since we might use some different units, different than kilograms and meters per second, it is worth mentioning that if you ever encounter a unit which is kilometer per hour, convert it directly to meters per second by dividing by 3.6. And if the mass is given in grams, divide by 1,000 to get kilograms. Sometimes we might have the ton as a unit. We multiply by 1,000 to get kilograms. Here is an application about kinetic energy. As usual, take a look, read it, try to solve it, and don't forget, in the fourth session, we're going to dedicate the whole session just to solve these applications. Now, the second part that we need to know before we move to mechanical energy is the gravitational potential energy. Here it's important to mention that when we say potential, it is anything which is stored within a system, within an object, and this object is capable of doing something due to that energy. Gravitational potential energy is the energy stored in the system due to the gravitational field of Earth in particular, and the position of that object with respect to Earth, or a reference that we choose. Now we need to talk about this a bit. If we go to another planet, we definitely have a gravitational potential energy. However, since in our exercise, we just deal with exercise on Earth, we just focused on Earth. Keep in mind that potential energy is energy that is capable of producing something. What is this something here? It is simply the force which we know as weight. Now, this is a bit beyond our chapter and beyond the level of this course so far. But it's important to notice or to mention that gravitational potential energy is the reason behind gravitational force, which we know as weight as well. Take this virtual example in which we have 3 bowling balls placed on the Pisa tower. Throwing the first ball from a certain height produces some work, some motion. So that bowling ball is capable of producing some work. This ball, if I release it, it will definitely move down. And I think you are all considering now that this ball is going to reach lower much faster. Not only that, if I consider this, the highest one, it's going to produce devastating results and very dangerous if you are beneath it. And yes, all of that is due to the height above a pre-chosen reference. Accordingly, in this exercise, we have chosen this reference to be this lowest point. Now, if you want to calculate the GPE, which is the abbreviation of gravitational potential energy, we have to consider two cases. If the object is above the reference level, as you can see in the figure here, GPE equals mass times gravity times h. Mass is in kilograms, gravity is in newtons per kilogram, and the height is given in meters. However, if the object is below the reference, as you can see in the figure as well, gravitational potential energy is minus mass times gravity times height. Height is always chosen as a positive value. However, we take into consideration whether the object is above the reference or below the reference. And don't worry, the reference is always given in the text of the exercise. Now, to make sure that you got this point, solve this application and check section 4 in order to check the solution. Now, ending the whole thing, we go to mechanical energy. Mechanical energy is simply the sum of kinetic energy and potential energies. Since we just deal with gravitational potential energy, so I've just written here m equals ke plus gp. So in general, we simply say mechanical energy equals kinetic energy plus potential energy in case we have other forms of potential energies. But the boundaries of our course on this level are simply using kinetic and gravitational potential energies. So why bother with other forms? Now, adding mechanical energy, which is the macroscopic external energy of a system, to the internal energy of the system produces what we call total energy. So this is just an idea that we need to know, because in real life we deal with total energy. If you remember the example of the rocket, or the example of the car, or the example of the bungee jumper, all these examples focus on the term of having mechanical energy and probably some other form of energy. The total energy of a system is the sum of mechanical energy of the system and the internal energy inside it. Atoms moving, molecules interacting. Probably in a car, two people are pushing each other. That's also internal. The total energy of a system is always conserved. It's never destroyed and it's never created. It is simply transformed. Okay? That's all concerning this session. I hope you got these ideas well. Don't forget, we need to focus on the equations over here, and you have the applications just to apply and make sure that you have got all the points that we need.